Hello students and welcome in the online session of class 9th Science chapter 10 Gravitation. This is the fourth video of the lesson. Let us see what topics will be covered today. Today we will learn about the weight of the object on the moon, thrust and pressure, density, pressure in the fluids, buoyancy, float or sink concept and Archimedes principle. So let's start first with the concept of what is the weight of an object on the moon. Now, the weight of an object on the moon is the force with which the object is attracted towards the center of the moon. As we have learned that weight on the earth is the force by which the earth pulls the object towards itself. Similarly, the weight of an object on the moon is the force with which the moon is attracting the object towards itself. Okay. Now let us consider that the object of there is an object of mass m. So m is the mass of the object. The weight of this object on earth is We. Right. So We is representing the weight of this object on earth. Mass remains the same whether the object is on the earth or moon. This we have discussed already in the previous lesson that mass does not change. Weight changes with place. So We is the weight of the object on earth. Now, according to the formula, W is equal to m into g, where g is the acceleration due to gravity. So here it is on the earth, so we are representing it with ge. Okay. Now, what is the value of ge? What is the value of acceleration due to gravity? The value of acceleration due to gravity is capital G, capital M upon Re square, right? So Re is representing the radius of the earth. Okay, small e in the subscript representing earth, and if there is small m, that means it is representing moon. So formula of acceleration due to gravity is gm upon r square. This is for earth. Now, putting the value of this g in the equation number 1, which is this, W is equal to mge. So, if we put the value of ge in this place here, so we get m, this m is as usual, and in place of ge, we have written the value capital G, then capital Me means mass of the earth upon radius of the earth and its square. So, just we have put the values and we get the weight of the object on the earth. Okay, I think this is not very difficult for you, because just what we have done, we have taken the weight formula, weight is equal to mg. Now we are using E because this is the object which is present on the earth. So W is equal to mg and g is equal to capital G into capital M upon r square. So just we have put the values, and this is the weight of the object on the earth. Similarly, the same formula will be applicable to find the weight of the object on the moon. So instead of using E as a subscript, now we are using M as the subscript here. So this will be the formula for the weight of the object on the moon. So Wm means weight of the object on the moon is equal to M capital G into capital M means this is the mass of the moon upon Rm means radius of the moon square. Right, so this is the formula for weight of the object on the moon. So here it is written that m is the mass of the moon, Rm is the radius of the moon. Now what we have to do, we have to divide this equation number 2 by equation number 3. Okay, it's written here 1, it's 3 here. So dividing equation number 2 by equation number 3. Now what we will get, let's see. So now dividing means we are dividing the weight of the moon by the weight of the earth. Okay, so you have to just put the values. We have already find the formula for weight of the object on moon and then the weight of the earth, weight of the object on the earth. So now just put the values. So mgm means this is for moon now. This value is of weight of the object on moon, mgm upon rm square. Now see, this weight of the earth is in denominator form, and if you will put it like here, it will be the third term. So what we have done, we have just multiplied it and reversed the term. Okay, this you have, I think this trick you all have studied in maths also. So multiply by, now the value of this formula will be reversed, because instead of division form now we are taking it in multiplication form, so the fraction will get reversed. So re square upon mgme. Okay, now if you will solve this, what will happen, that mass of the moon upon mass of the earth, what things get cancelled, right? This m get cancelled. Okay, this m get cancelled, this g get cancelled. So what is left now? mm into re square on the upper side, and me here is me into rm square on the other side. So instead of putting separate squares, they have just put it in a bracket and whole twice, means the square is on both of them. Now if we put the values of all these, right, mass of the earth, mass of the moon, radius of the earth and radius of the moon, and solving it, we finally get this ratio. That means weight of the object on the moon is equal to 1 upon 6th of the weight of the object on earth. That means simply you have to just learn this equation, this relation, that weight of the object on the moon reduces to 1/6 of what the weight of the object is on the earth. Suppose on the earth the weight of the object is 80 kgs. Right, suppose the weight of the object on the earth is 80 kgs. So what will be the weight on moon? So what you have to do, you have to just divide it by 6 and you will get the weight of the object on the moon. Okay, so 1/6 of the weight of the object on the earth. On the earth, if it is 80 kg, then divided by 6. If the weight is 30 kgs on earth, then again what you have to do, you have to divide it by 6 and you will get the weight of the object on moon. So it will be 5 kgs, right? 5 kgs on the moon. If any object is 30 kgs on earth, it will be 5 kgs on moon. So this is the relation which you have to just learn. No need of learning all this derivation, but what we have done, we have just simply put the values in the formula and finally you get this relation. One weight of the object on the moon is equal to 1 upon 6th of the weight of the object on the earth. Okay, so if you know the weight of the object on the earth, you have to divide it by 6 to get the weight of the object on the moon. If you have the weight of the object on the moon, then by multiplying it with 6 you will get the weight of the object on the earth. So this is the relation between weight of object on earth and weight of object on moon. Now let's move on to the next slide and see the concepts of thrust and pressure. So a body always exerts a force which is equal to its weight on any surface supporting it, right? Suppose this is the ground and there is a box lying on this surface. So this box will apply some weight on the surface. Now how much weight it is applying? It is applying the force which is equal to its weight. Okay, if suppose it has 30 kg weight, that means it is applying a force of 30 newtons on the surface. So a body always exerts a force which is equal to its weight on the surface. Now the force which is acting normally on a surface, okay, what I said, the force which is acting normally means perpendicularly. Here you can see force acting perpendicular to the surface. Here in the diagram it's very clear. Suppose A is the surface and on this force is acting in perpendicular direction. So this force is called as thrust. Fine. So what is thrust? Thrust is the force which is acting on a surface in perpendicular direction. Normal means at 90 degrees. So that force is called as thrust. Now this thrust is a vector quantity, not a scalar quantity, because it has magnitude as well as it has direction. It is acting in downward direction, right? Vector quantity means which has a magnitude, means a value plus a direction. So thrust has both the things, that is why it is a vector quantity. And because it is a force, so its unit is Newton, right? So its unit is Newton. Now what is pressure? So pressure is the thrust acting on unit area of the surface. Pressure is the thrust, that means the force which is acting on a unit area. Force upon area is called as pressure. Okay, in unit area means in 1 centimeter square or in 1 meter square or in 1 kilometer square, whatever field. In unit means 1. So it can be 1 centimeter square, it can be 1 meter square. So the thrust which is acting on unit area of the surface is called as the pressure. Its formula is P is equal to thrust. Thrust means force only. So force upon area is called as the pressure. And what is thrust? Thrust means the perpendicular force acting on the surface is called the thrust. Now this pressure has a different value, different unit. It's Pascal, and it is denoted by the symbol capital P and A. Right? Don't read it as Pa. It's Pascal. So symbol is capital P and A. So 1 PA is equal to 1 Newton per meter square, right? Force, because its formula is force upon area. Force is measured in Newton and area is measured in meter square. Okay, and for pressure we said that 1 Pascal, means Pascal is the unit. So 1 Pascal is how much? 1 Pascal is equal to Newton meter square. So you can use Newton per meter square, or you can directly use Pascal only. Right? So 1 Pascal. Now how can we define 1 Pascal? 1 Pascal means when 1 Newton force is acting in 1 meter square area. Okay, 1 Pascal is that force which is acting on a unit area. That is called as 1 Pascal. 1 Pascal is 1 Newton force which is acting on the area of 1 meter square. Fine, this is how we define the units also. Now, next is density. Now, density of a substance is the ratio of mass and volume. Density of any substance can be defined as its mass per unit volume. The ratio of mass and volume is called as density. It is denoted by the symbol small d. So d is equal to what? M upon V. Now let's see what is the unit of density. Unit of density is kg per meter square. Why kg? Because mass is measured in kilograms, volume is measured in meter cubes. Right? Volume is equal to length into breadth into height. So m raised to the power 3. So unit of density is kg per meter cube. So this is about density. Now next concept is relative density. Relative means we are finding some relation with the other thing, then it becomes relative density. So relative density means density of the substance divided by the density of water. Okay, if you don't write at 4 degrees Celsius, then also it's correct. You can simply write density of a substance upon density of water. If you find the relation or the ratio between density of the substance, whatever substance is with you, and density of water, then it gives you the relative density. And it has no unit, because we are just finding the ratio of these two densities. Okay, so both are densities, so both units will be same and they will get cancelled. Okay, right, density of a substance will have kg and per meter square, per meter cube, sorry, and this density of water will also have the same unit, so both will get cancelled. So relative density has no unit. Now you can see in the diagram that density is what? Density is mass per volume. Volume is the area. Volume means the area. Okay. So here you can see that in this area, both the areas are same. Okay, area number 1 and 2 are same. Here you can see that the molecules which are present in area number 1 are less, means the mass of these molecules will be less. Now in case 2 you can see that many molecules are present, more molecules are present, so their mass will also be more. Okay, so when the mass is less in a particular volume, its density will be less. Now when the mass is more, density will be more, because density and mass have direct relation. Okay, and volume and density have inverse relation. If the volume is more, density will be less, because if the area is more, what will happen? These molecules will get spread away, so density will decrease. Okay, so these diagrams can clearly indicate that when the molecules are more, when the matter is more in the given volume or given space, its density is more. And if the molecules in a given volume are less, that means its density is less. Like if you can see the example, you have milk, right? One of the liquid you have milk and one is honey. Okay, so there are two liquids with you. Now which one of them is more dense? So you can say honey is more dense. right? Why honey is more dense? Because there are more number of molecules present in honey than milk. Milk can easily flow, but honey cannot, because density of honey is more. Okay. Now, next one is pressure in the fluids. So what are fluids now? Fluids are liquids and gases. Liquids and gases together are called the fluids. Or you can say that any substance which can flow is called as the fluid. Now if that fluid is contained in a vessel, right? If that fluid is contained in the vessel, that means there is a vessel and you have put the fluid inside, then what happens? This fluid will exert pressure in at all the points of the vessel. So this fluid which is taken in the container will apply pressure at all the points, okay, and in all the directions. Everywhere this fluid will exert pressure on the walls of the container. Okay, this is the pressure in fluids. That means fluids exert pressure in all the directions at all the points of the vessel. And from this only the Pascal law is given by Pascal, and according to it, in an enclosed fluid, that means in an enclosed vessel, some fluid is present. Now there is a ball, as a ball, or you can say it's a container having the circular shape and a fluid is filled inside it. So in an enclosed fluid, if the pressure is changed in any part of the fluid, then that change in the pressure is transmitted undiminished, means without fail, without any change. That pressure will be transmitted to all the parts of the fluid. That means what? Just see the diagram. Here it is shown that external pressure is applied here, means this is a balloon, you can say, or it's a ball and water is filled inside. Now if the ball is squeezed, right, if it is squeezed, means if pressure is applied from both the sides, from this side and this side, so ball gets squeezed. So what we are doing, we are applying pressure on it. So when this pressure is applied, now what will happen? That fluid which is filled inside will exert equal pressure in all the directions, and the liquid will squeeze out through the small holes, as you can see in the diagram. The liquid is just squeezing out from this vessel. Okay, and you can see equal amount of fluid is coming out, because the pressure which is generated at one point, at this point, is transmitted in all the direction. Right, this is what Pascal's law, that whenever in an enclosed fluid any pressure is applied, so that pressure is transmitted to all the parts of the fluid. Okay, and that is called as the Pascal's law. I hope it is clear to everyone. Okay, so pressure applied on one point of the liquid transmits equally in all the direction. If you apply pressure on one part of the liquid, that pressure will be transmitted to all the parts of the liquid. This is the Pascal's law. Now in the next slide we have to study about buoyancy. Okay, buoyant force also you can say. So whenever a body is partially or wholly immersed in a liquid, right, if you are partially or completely putting any object, any body in the liquid, then what will happen? An upward force acts on it. Okay, from the liquid side an upward force is applied on it, and that force is called as upthrust or the buoyant force, right? As you can see in this diagram, that this is an object which is immersed in water, right? So this object has weight. So this weight of the object, this much force is applied in the liquid in the downward direction, and the liquid in turn is also applying some force in the upward direction. Okay, and that force is called as the buoyant force. Right, if you have a ball and suppose you are trying to push the ball in water with your hand, what happens? When you will leave the ball will again come up on the surface of water. This is why, because the liquid has applied the buoyant force on the ball in upward direction. Remember, this buoyant force is applied by the fluids in upward direction only. That is why it is called as upthrust also. Okay, and this property of the fluid of exerting an upward force is called as the buoyancy. So buoyancy is the property, and the force which is applied, you can say the buoyant force. Right, the force which is applied is buoyant force, and this property of the liquids to exert an upward force is called as the buoyancy. Right, now here in this diagram also you can see that gravity is pulling this boat downside. This is a boat on the surface of water, so gravity is pulling it down, but this fluid is exerting an upward force which is called as the buoyant force or the buoyancy. Okay, so this is about the buoyant force. Now let's see why the objects float or sink. Which objects will float on the surface of water and which objects will sink down? So see, two forces are acting when the object is put in water, as we have already discussed. One is the weight of the object and other one is the buoyant force. Both are acting. So in terms of both of these, we will find out that which objects will float or sink. Now a body sinks when its weight is greater than the buoyant force. Okay, means weight is applied in downward direction, because you have studied that weight is nothing but the force by which the earth pulls it in the downward direction. So this is, you can say, gravity or the weight of the object which is acting in downward direction, and buoyant force is acting in upward direction. Now if the weight of the body is more, okay, what I said, if the weight of the object is greater and this buoyant force is less, then what will happen? Weight is more, that means the body will come down and sink at the bottom. And if the buoyant force is more, if this force from the lower side is more than the weight of the object, then what will happen? The object will float. Okay, it's a very simple relation, because two only forces we are considering. If the weight is more, which is acting downwards, that means the object will go down and sink. And if the buoyant force which is acting in upward direction is more, then what will happen? The body will float on the surface of the water. Or in terms of density, if we want to see, then if the density of the body is less than water, then it will float. Okay, if the density of the object is less than water, then what will happen? The object will float on the surface of the water. Here you can see in this diagram, see, density of the object is less than the density of water. That means it is floating upside. If the density of the object and the density of the water are equal, then the object will, get submerged in between water. It will not sink, it will not float. It will just, be present in the center of the water like this. And if the density of object is more than water, then it will sink at the bottom. Right? Why ice floats on the water? Okay, so what is the reason? Density of ice is more or less than water? Okay, so answer is what? That it is floating on water. We know ice floats on water. That simply means that the density of ice is less than the density of water. So if the density is less than water, it will float. If the density is more than water, then it will sink down. So this is the concept of floating and sinking. Now the next and the last topic of the lesson is Archimedes principle. This principle was given by the scientist Archimedes, and that's why the name is only Archimedes principle. So according to this principle, when a body is immersed partially or wholly in a liquid, means whenever we will put a body inside the water, either partially, means half of the body is in water, or if the object is completely dipped in liquid or water. So whenever the body is immersed means dipped partially or wholly in liquid, then it experiences an upthrust. We know that whenever any object goes in water, the water will apply not only water but any fluid. So that fluid will apply an upward force, which is called as upthrust or the buoyant force. So whenever any body is partially or wholly dipped in liquid, it will experience an upthrust, and that upthrust is equal to the weight of the liquid displaced. Right? When this body will go inside the water, what will happen? It will displace some water. It will displace some of the water, because it is going inside water. So some of the water will be displaced from its position. So weight of that displaced water is equal to the buoyant force applied on the object, and this is called as the Archimedes principle. So let's see with an example. See, this is an object of 10 kg weight, and now we are immersing it in water, right? So in the second diagram, you can see that it is immersed in the water or any of the liquids. Now see, it is completely immersed in liquid. Okay, so now you can see that the reading here shows that 4 kg is the buoyant force. Okay, and you can see here that this row, this much, is the 4 kg of water displaced. Right? If you remove it out, this much water, you can see that this much is the level increased of water. Right? This much. If you mark it, and then you can see that this much column of the water is increased. That means this much water is displaced from its position. Okay. So Now this much, the weight of this much water is 4 kgs. So 4 kg is the weight of the liquid which is displaced, and therefore 4 kgs buoyant force which will be applied on the body. And here with the spring balance it can be noticed that here, see, here it is written 5 and here it will be what now? Okay, so readings can be seen here. Fine. So therefore, because this 10 kg object displaces 4 kg of water, so it feels like it only weighs 6 kgs underwater, right? So here the reading is 6. So when the object is immersed in the water, it displaces some of the water, and the amount of water or the weight of the water which is displaced, it is equal to the buoyant force. And whatever is the buoyant force, that much less will be the weight of the object in the water, right? Whatever is our weight outside the water is not the similar when we are in the water. When we are in the water, we feel little lighter than when we are outside the water. So how much light an object will feel inside the water is that 4 kgs is the buoyant force applying here. So what will happen? Now the weight of the body inside the water will be only 6 kgs. Okay, already it was 10 kgs, but when it go inside, it displaces 4 kgs of water. That means the body inside the water will weigh only 6 kgs, as 4 kgs of the water is displaced and 4 kgs buoyant force is applied from the lower side. Okay, this is Archimedes principle. Now suppose another example I am giving you, that we have immersed a body of 20 kg inside the water. Okay, so you have immersed a body of 20 kgs inside the water and the object is here now, suppose. So now what will happen when you will immerse in water? Suppose a 5 kg buoyant force is applying from the lower side, because this body has displaced, suppose, 5 kgs of the water. Okay, so 5 kg buoyant force will be applied from lower side. Now what will be the weight of the object inside the body? We will minus this 5 from 20. Because 5 kg water is displaced, 5 kg buoyant force is applied. So what is the weight of the object in body? It will be only 15 kgs. Okay, and that is the reason, because when any object is inside the water, it feels weightlessness or very lightweight, right? The weight gets reduced when the object is in water. And how much it is reduced? It is equal to the buoyant force which is applied from the lower side. And how much buoyant force is applied from the lower side? It is equal to the amount or the weight of the water which is displaced with the help of this object. I hope this Archimedes principle is clear to you all. So when a body is immersed partially or wholly in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced. Okay, if 4 kg water is displaced, 4 kg buoyant force will be applied. If 5 kg water is displaced, 5 kg buoyant force will be applied. If 10 kgs of water is displaced, 10 kg will be the buoyant force applied from the lower side. And whatever is the weight of the object, so this much weight, this much value which is of the buoyant force will be minused or subtracted from the total weight of the object. That means that much is the weight of the object underwater, right? So here in this example you have seen that 10 kgs object was kept in water, so it displaced 4 kgs of water, so buoyant force applied is 4 kgs, and 4 kg less weight will 4 kgs weight will be less from the total weight of the object. If the object was 10 kgs, so minus 4 kgs, so now its weight in water is 6 kgs. Okay, so I hope this is clear to everyone. Now let us see what are the applications of Archimedes principle, where this concept is used. So it is used in designing the ships and the submarines. Fine. So what is according to Archimedes principles? More the weight of the object or more the water it will displace, then more will be the buoyant force, right? What we have learned, that more the weight of the liquid will be displaced, more will be the upthrust, because this upthrust and the weight of the liquid displaced are equal, right? So if the size of the ship is very big, okay, or if the weight of the object is very large, then it will displace more water from the place. and more the water displaced, more will be the buoyant force which is applied from the downside. Okay, fine. So that is why the ships are designed and submarines are designed in such a way that they can displace more water, and when more water is displaced, more buoyant force is applied from the liquid side. Okay, so this is the application of Archimedes principle. And then designing lectometers. Lectometers are the device which is used to find the purity of the sample of milk. So in designing lectometers, the design is such that more liquid can be displaced and Archimedes principle can be used. Then in designing hydrometers, hydrometers are also the devices which is used to find density of a liquid. Okay, so designing ships and submarines. Okay, the ships and submarines are designed in such a way that they can displace more water. If more water is displaced, more buoyant force will be applicable to the object and it will easily float on the surface of the water. So these three applications you have to learn: designing ships and submarines, designing lectometers, designing hydrometers. Here you can also see the example of a balloon. See, more the very big size of the balloon will displace more air, and more air will be displaced and more buoyant force will be applied. Air is also a fluid. Okay, liquids and gases both are called fluids, and fluid word is used. So more the area, you see how much the size of the balloon is. So what will happen? More air will be displaced. More air will be displaced, so more upthrust will be applied by the air, and the balloon can easily fly in the air or go at the higher positions in the sky, right? So this is about the applications of Archimedes principle. These are very short concepts, but just you have to learn the definitions and try to learn and understand them, right? No need of mugging these concepts, just try to understand them. So we have come to the summary that what is the weight of the object on moon? It is 1/6 of the weight of the object on the earth. Then thrust is the force acting in perpendicular direction. Pressure means force upon area. Density means mass upon volume. Pressure in liquids and fluids. Fluids apply equal pressure in all the directions, right? Buoyancy is the upthrust or the force applied by the fluids in upward direction. Float and sink concept we have understood, and Archimedes principle also we have understood that whenever an object is dipped in any of the fluid, then the upthrust is equal to the weight of the water or the fluid which is displaced from its position. So that is Archimedes principle. Okay, so this lesson is over here. All of you please do complete your notes and exercise questions and read the lesson from your textbook. That is a must. And apart from this, stay home, stay safe and keep learning.